Hello and welcome to CON 215, Samsung Smart TV Globally Scaling with AWS Fargate Spot session. My name is June and I'm a solutions architect from AWS. I'm joined by a team from Samsung Electronics Visual Display Division. We have Junhyuk and Kyungshik. We'll be looking at how Samsung was able to utilize AWS Fargate to scale their application to support customers globally. As a quick sneak peek of today's session, we'll be looking at what is Samsung Smart TV Service, for those who are not familiar. Secondly, we'll be looking at Samsung Smart TV team's migrations journey to AWS. And then we'll look at why AWS Fargate was used, and also look at how AWS CDK helped Samsung with automations and multi-region deployment. And finally, we'll look at some of the cost optimization methods that were used. So before we dive deep into Samsung's Fargate journey and its details, I'd like to invite Junhyuk to start by introducing Samsung Smart TV and its behind the scenes to the audience. Junhyuk?
Hi, my name is Junhyuk Song, working in apps service team at Samsung Electronics Visual Display Division. I'm gonna talk about what we've done during the long migration journey to AWS for the past 4 years. Before I go into migration journey, let me introduce Samsung Smart TV service. The traditional TV was only focused on the technical features such as picture quality and performance. But now, TVs are also a lifestyle platform that blended in consumers' daily life. The frame and shelf TV go beyond the traditional TV to pieces of home decor that elevate the design of any living space. The Zero is mobile-friendly TV, and it is able to rotate horizontally and vertically. Samsung TV keep trying to go beyond the traditional concept of a TV. Samsung has maintained its #1 position in the global TV market for 14 consecutive years. 140 million Tizen TVs are connected to the internet from 197 countries. The Tizen is an open source operating system based on Linux, leading by Samsung. Since 2015, all smart TV features are working on customized Tizen TV platform. For quick access to content, 3 partner application buttons are provided on remote controller, so users can launch application with just 1 click. Samsung TV Plus is an exciting and diverse collection of free live, linear, and on-demand content. The Samsung TV Plus experience gives users instant access to leading international news, sports, and entertainment channels. You can enjoy live and on-demand TV channels for free. You don't need additional software downloads, subscriptions, or hardware accessories. Also, Mobile TV Plus has been launched in September, so users can watch the content on mobile too. People spend 50 minutes per day to search for content they like to watch. To help viewers reduce their time to get to the content they like, Samsung came up with the Universal Guide service, which discovers content matching with the user preference via preference and history. The last service is the app service, a platform server for app content distribution. The apps service consists of Smart Home, App Store, and out-of-box experience promotion service. Smart Home, named Eden, gives easy access to popular streaming services like Netflix, Amazon, and Disney Plus, including content preview. Apps service has launched in 2010 and now serving trillions of requests per month from all over the world. Today's topic is about app service migration journey. trillions of requests is something which not every application is able to handle, but due to Samsung Smart TV's presence all over the world, we have to evolve. Now, let's move on to the main topic. Let's look at the background first to explain where we were. There was only one monolithic application with a single massive Oracle database in on-premise data center. Because we used one massive database, we had to scale up for database scaling with service downtime. And cost optimization also was impossible according to traffic demand. The biggest problem was the wide effect on smart TV users by system failures because apps service is the entry point service for Smart Hub. To fix these issues, in 2013, we have to try to migrate to AWS with a lift and shift approach, but failed because database performance was not enough as much as we expected. After 2 migration attempts, we realized that migration is impossible without architectural changes when migrating services that are large or even massive scale. At the time, Oracle database had to be run on EC2 due to its scale, but was not able to fully support our scaling needs. There was another background in terms of the developer's life. To be honest, this background was the most important point from my perspective, and it's due to time zone. When do you watch your TV? Most people watch TVs around 6 or 7 p.m. when having a dinner, and 9 a.m. before going to work. Like the second screenshot, the peak time for TV viewing from other parts of the world is equivalent to 2 a.m. my time. So in case of capacity or peak traffic causing problem, the developer have to handle alarm at 2 a.m. if there were any issue. The business continuity is critical, but so is the developer's life. Work and life needs to be balanced. No one likes to receive an alarm and phone call at 2 a.m. due to a system failure. It actually happened around 2 a.m. My wife woke up due to several SMS alarms that I failed to acknowledge and asked me to check whether there is a problem. Therefore, we have approached using cloud-native application and microservices adoption using AWS managed service and multi-region infrastructure architecture. We wanted to focus on developing business logic without putting extra effort on infrastructure operation and monitoring, because I'm working in apps service team, not operation team. Let's look at more closely on AWS migration based on the cloud-native architecture and microservices adoption. This migration has been ongoing for the 4 years with the architecture enhancement in every part of the way. We have built microservices one by one, working on services with less blast radius first. Since 2015, all the RESTful API applications have been running behind the API gateway. This allowed us to segregate applications with any changes required from Smart TV client side. To change from scale up to scale out for database, we decided to migrate database from Oracle to Aurora MySQL with multi-region deployment. First, let's look at our architecture before the migration. At the time, applications were running in on-premise data center, so it was difficult for scaling and cost optimization. When a system failure occurs due to database, there was huge effect on smart TV users. In the new architecture, Major changes are multi-region architecture and auto-scaling for web application and database. There is the CloudFront in front of Smart TV API gateway servers to protect from DDoS and reduce network latency and cost. To process the global traffic from geographically distributed server, Smart TV API gateway servers are running in 6 regions, and apps service applications are running in 4 AWS regions, including China Ningxia region. China region infrastructure is managed by China R&D Center independently. Almost traffic more than 90% HTTP APIs response from cache by API server layer. When Smart TV requests APIs, traffic will be routed through CloudFront API gateway server and ALB. And Fargate containers handle business logic and data is stored in Elasticache and Aurora. Region-aware configurations are managed by Route 53 and Spring Cloud Config. Finally, auto-scaling has been adapted to both API application and Aurora in 4 regions. Next, we will look at why ECS and Fargate was adapted and how we came to this conclusion. All things running the application, such as application runtime, library, configurations, and tools were saved into one container image. Because of this characteristic, scaling is easier compared to virtual machine or EC2. And resource utilization can be optimized by CPU and memory reservations. So the cost can be heavily optimized. The biggest change was to change the way of thinking. Because a container can be terminated at any time, it was not easy to change our development principles and also stateless applications. To build once, deploy anywhere, all configurations are moved to Spring Cloud Config and ECR immutable option is used. When deploying the application on production stage, pull container image from staging ECR and push to production ECR and deploy without build. There were 2 times ECS migration. In phase 1, applications have migrated from on-premise data center to ECS with step scaling. In phase 2, have migrated from ECS to Fargate Spot with target scaling and CDK. Let's talk about each phase in detail. In phase 1, we have used ECS using EC2. Like the diagram, when 2 core and 2 GB task applications try to be deployed, EC2 instance had to be created, but not created automatically. So cluster management is needed by developers like CPU utilization-based task scaling and memory reservation-based EC2 cluster scaling. After ECS migration, to increase operational efficiency, we looked into AWS Fargate. Let's compare ECS using EC2 with Fargate. Dynamic port mapping is in ECS using ECS is complex to monitor, where people usually need to adapt service mesh to go around this problem. But Fargate is micro virtual machine and port is fixed. The biggest advantage is no need for cluster management and pay for what you use. But there is one difficult thing, and you need to know that developers can't connect into the container when the application performance issue occurs. For this reason, we have adopted AWS X-Ray for Fargate. On the previous slide, I shared the capacity for virtual machine has not been managed automatically. To help cluster management, the capacity providers had been launched in December 2019. Developers can set providers with base and weight options and can be mixed with multiple providers like a screenshot. In case of app service, we are successfully running on Fargate Spot for all API applications with multi-region architecture. As you can see from the subtitle of this page, it's a beautiful chart. This graph is a summary result of our migration and how we operate now. The left blue line is the request count of ALB, and the right orange line is health host count for 3 days for production. According to traffic demand, ECS tasks will be added or removed very quickly based on the target scaling policy. We use the target scaling with the target value of 40 CPU utilization. This allowed us to scale at close proximity according to an actual traffic. I would like to share more on resource utilization in microservice. In phase one monolithic application is separated into multiple micro applications into one shared account. In phase two, to operate infrastructure independently, applications migrated into 4 AWS accounts again with account segregation using CDK. So, cluster scaling unit should be smaller than before in microservices. 3 types of CPU and memory reservations were used according to domain logic and traffic volume. All resources have been migrated using CDK for Fargate and account segregation in the second migration. Let's talk about changes by CDK and how to deploy the infrastructure by using CDK. I'm going to talk about changes by CDK. Before using CDK, responsibility have shared between infrastructure team and service application team. After CDK adoption, application and infrastructure are both managed by service team. It was a significant change in terms of productivity. Of course, AWS account segregation from a shared account is required for the security. There was 2 consideration points when we manage infrastructure using CDK. In terms of security, developers needed more privileges than before, and we wanted to manage the history tracking. What's the changes and who deployed the CDK code? So based on the 2 major backgrounds, we have deployed using Assume Role and Jenkins. For the productivity, the shared IAM key is used only for development stage, and CDK code has deployed from developer's desktop. In case of QA and production stages, Jenkins pipeline is used, such as application code deployment. Let's see the flow, how we deployed the CDK code on Jenkins between DevOps account and service account. First, check out CDK code from Git, run assume role command to get an IAM key and secret key and temporary token. After that, using this key and token, run CDK diff command. In step 4, to review changes before deployment, we use the manual judge step with the timeout on Jenkins. After confirmation about changes, deploy using CDK deploy command, then changes will be reflected to CloudFormation. To prevent deletion, enable the termination protection and archive JSON CloudFormation template files. As a final step after deployment, JSON CloudFormation template files will be committed to Git for history tracking. To summarize, The first migration from on-premise to container used the ECS, AWS Batch, and Aurora adoption that allowed us to benefit from containerization and managed service. The second migration from 2019 architecture to 2020, where we migrated from ECS to Fargate, truly freed us from operational pain. And there is no virtual machine except for EMR, and adapted CDK for multi-region and DevOps strategy. I would like to invite my colleague Kyung-sik to share us on how Fargate and AWS was able to help us with cost optimization.
Thank you so much for having me. My name is Kyung-sik Myung, and I'm in Cloud Infra Operation Team at Samsung Electronics Visual Display Division. Today, I'll be introducing what we have done to optimize cost with the AWS ECS Fargate migration. Let's look at what we did and how much was actually saved. Before we talk about cost optimization result, first we need to know how to compute resource cost. Then I'll tell you how we saved it. Compute cost is calculated with three components: number of compute units, time in use, and cost per unit. So our team focuses on each of these components to save cost. First part is number of compute units and time in use. When we use on-premise, we have to reserve lots of compute resources with a long-term commitment, and it was difficult to scale out or scale in. Of course, it was expensive and hard to manage. However, when we use AWS Fargate, we don't need to worry about that anymore. We only need to pay for containers as much as we use. It's easy to increase or decrease the desired count of tasks in our AWS ECS service automatically. So we can reduce cost during low utilization. By using AWS Fargate, we could save cost, and also we don't need to manage servers anymore. But we did not stop here. We needed to monitor each cluster, service, and task to make it more cost optimized. When you run your tasks and services with AWS Fargate, you need to specify the CPU and memory requirements. As we said, AWS Fargate makes us free from EC2 development, auto-scaling, and security issues. But still, it costs based on specified CPU and memory. That's why we have to monitor and prevent over-provisioning. To optimize and monitor our team-built container monitoring system using AWS CloudWatch Container Insight. This monitoring system collects metrics such as CPU, memory, disk, and network. We can check how many services and tasks are running, or pending, or in healthy state. As you can see here, this monitoring system helps us observe CPU and memory utilization. Based on this data, we could find optimized CPU and memory requirements. So we could estimate right number of compute units and reduce unnecessary time in use. We have talked about number of compute units and time in use. Now we will talk about reducing cost per unit. We use the Fargate Spot instances to reduce cost per unit. Fargate Spot concept is the same as EC2 Spot instances. We can use spare Spot capacity to run our tasks. AWS Fargate Spot gives us up to 70% discount, and it's huge. In addition to Spot instances, we also use compute savings plan. This is a commitment to use a specific amount of compute usage for 1 or 3 years. To use the savings plan, we need to know baseline computer usage in advance. Using our monitoring data, we estimated our baseline computer usage. It's very easy to use the savings plan. We just need to select the type of plans, term lengths, and payment options. And that's it. And we can receive significant discount. We have talked about how our team worked to save costs. First of all, we migrate our services from on-premise to EC2-based ECS, and finally to Fargate. Then we utilized Fargate Spot and savings plan. As a result, our usage cost is now decreased by 63%. Achieving 63% cost saving was a great effort, and we nailed it with our team's cooperation. With this saved budget, now it's possible for us to reinvest and provide better quality service to our customers. To conclude, there is nothing we need to do after production deployment because auto-scaling is working fine and quickly every day. And we don't need to consider capacity as we use Fargate. Nowadays, I'm in a deep sleep every day without any alarm or system failure. Thanks, Fargate and Aurora. I really hope that today's session was able to give you insight on how Samsung and AWS was able to work together to bring operational efficiency, cost effectiveness, and let him focus on business innovation. I would like to thank AWS for having us here and everybody online for joining us today. Please remember to complete the survey and hope you all enjoy the rest of reInvent 2020. Thank you.